As you will remember, we had 78% of nitrogen in the air and 21% of oxygen. Now, I will show you what oxygen looks like when it's liquid, and I will also show you the property of oxygen to enhance any fire. Oxygen is needed to burn things, and when we have much oxygen around, things will burn very much. Now here you see this is liquid oxygen, and you can see the slight blue color. And now I here have just one ordinary wooden stick, which I'm setting fire to. And you see it's this very small flame burning, and when I take this small flame and go down in the pure 100% oxygen atmosphere, you can see how fiercely it starts to burn. And in the inert gas, I can get this to extinguish. When I'm very quick, I can show this very funny effect that this is just glowing, and it ignites, it goes out, ignites, goes out, ignites. A little bit of glow left is just sufficient to make things burn, and as you can see, it burns fiercely down in the oxygen. So the wooden stick would burn fiercely in the oxygen, and this was a very concentrated atmosphere. We were above liquid oxygen. Now imagine that the oxygen in this air in the room or elsewhere where we are working is just enriched. This means some percent more, which might be the case when welding in a closed, confined area, or when we have a spillage of oxygen. And imagine now that you enter with your clothes burning. I will show you an example. And I'm pouring some oxygen down here into my aquarium. And now the oxygen is boiling off there, mixing with the air, and also at the same time now pushing out the nitrogen. So we get an oxygen-enriched atmosphere. And you are very unhappy because your clothes were burning. And now you see what happens when you enter this room. So you had better not enter this room. Now you will see the same effect, but more or less real size. Even protective clothing made of cotton like this are not combustion proof, but will therefore have to be chemically treated to be resistant against flames and to retard ignition. However, you will have to remember that laundry will remove this agent, and treatment of the fabric will have to be repeated. Now we are testing what is happening when we enter an oxygen-enriched atmosphere and then expose the clothes to sparks and molten metal from a cutting operation. Here we now simulate a large oxygen leak, and we see that the oxygen concentration in the confined working area is climbing to about 38%. We start cutting from outside and thereby inside drenching the clothes with molten metal. You can see they do not ignite immediately, but when they start to burn, they burn fiercely. You can see that this working shot has taken up more oxygen in the thicker seams. And here is a woolen sweater which is partly synthetic. All the microfibers on the surface help to spread the fire, and remember that synthetic fabric is dangerous. It not only burns, but will melt and cling to the skin.